In graphing this polynomial function, the first thing we'll decide is the degree. The degree is 3, and that's an odd number, so let me write that. The degree is 3, which is odd. And after then, we are going to look at our leading coefficient. Our leading coefficient is -1. Therefore, the graph is going to behave, the ends of the graph is going to behave like a line that has a negative slope. We are only talking about the ends of the graph, so we are talking about these two parts. In the middle, there will be some curves. So when I look at the end behavior, as x goes to positive infinity, that means I'm going to the right. My f of x is going to negative infinity. And as x goes to negative infinity, my function f of x will go to positive infinity. After deciding the end behavior, we can start filling out our table of values using syntactic substitution. So I will start with -4. And when I look at the function, the x squared term is missing. So I have -1, 0 is for the placeholder, 2 and -1. So I have -1, and then I multiply by -4, get 4. Then I get -16, -14, and the last value is 56. If I add 56 and -1, I will get 55. So my first function value is 55. Then I do the second one, -3. -3, I have -1, 0, 2, -1, 3. I get 3, -9, -7, and 21, and the function value will be positive 20. And I do -2, -1, 0, 2, -1. And my function value at the end is going to be 3. At -1, I have the same values in the top row. And I get -2 for the function value. At 0, we get -1. At 1, we are going to get zero. At 2, we get -5. At 3, we get -22. And at 4, we get -57. All I have left is to graph these ordered pairs. So I'm going to go by ones on the x-axis and I'm going to go by tens on the y-axis so that I can fit all my numbers. So the first ordered pair I graph is -4, 55. Then I have -3, 20. Then I have -2, 3. Then we have -1, -2. 0, -1. 1, 0. At 2 we have negative 5. At 3 we have negative 22. And at 4 we have negative 57. So I'm going to connect these points, moving from left to right. And I need to make sure that I connect the points with a curve, including every one of my points. Since I'm using a stylus, my graph is just a tiny bit off in this area. In today's lesson, we are going to add, subtract, and multiply polynomials. And the first thing we are going to do is we are going to recall some of our special patterns. The sum and difference pattern, which is a plus b times a minus b, a plus b times a minus b, gives us the differences of squares, a squared minus b squared. Then the square of the binomial, a plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. And we are going to learn a new pattern, which is called a cube of a binomial. When I multiply a plus b times a plus b times a plus b, the answer will look like a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus b in parentheses to the third power is a cubed minus 3a squared b plus 3ab squared minus b cubed. Yes, you will have to memorize these formulas for the quiz and the test. In these examples, we are going to use the horizontal and the vertical method, first to add polynomials and then to subtract polynomials. Notice that when we are using the vertical method to add polynomials, we are lining up our like terms, so then we can just simply add. So when we add the like terms, we are going to get 2x to the second power minus 5x minus 8. And that's our final answer. When we have our horizontal method, when we are adding, we are going to distribute 1 basically, so we can just take away the parentheses. X to the fourth plus 2x to the third plus 8 plus 2x to the third minus 5x. And I simply combine my like terms. I only have 1 x to the fourth. I have 2x cubed and another 2x cubed, which will give me 4x cubed. I have a negative 5x. And lastly, I have my number 8. And notice that I wrote both these polynomials in standard form. When we subtract the polynomials with the vertical method, again we have our like terms lined up, but we have to be careful because in this case we are subtracting. So I start with 3x cubed minus 5x cubed, which will give me negative 2x to the third power. Then I have 8x squared, take away a negative x squared, which will give me plus 9x squared. Then if I look at my polynomial, negative x, and I don't have any x terms underneath, so I'm going to just say negative x. And last I have negative 5, take away 17, which will give me negative 22. And again, I wrote my polynomial in standard form. If I do subtraction in horizontal method, I will need to distribute the negative 1. So I rewrite the polynomial as 9x to the fourth minus 12x to the third plus x squared minus 8 minus 3x to the fourth plus 12x to the third plus x. And all I do is combine my like terms. I have 9x to the fourth minus 3x to the fourth, which gives me 6x to the fourth. I have a negative 12x cubed and a positive 12x cubed. So, and since they are opposites, they go away. Then I have an x squared. So I'm putting my positive x squared, which is right here. I'm going to do that, underline that in blue. And then I have one of the x's, so I'm going to do plus x. And lastly, I just have one number, which is negative 8. And this way I have my polynomial in standard form.